In today's lecture, we will discuss the advanced electromagnetic structures. When the students work on metamaterials or frequency selective surfaces, they are confused that what is the difference in between these terms like metamaterial, frequency selective surface, electromagnetic bandgap, defective ground structure, Chiral Metamaterial. So in today's lecture, I will try to explain all these terms in very superficial manner and try to solve your queries. So in traditional electromagnetic engineering, we have different kind of structures like waveguide, antenna, microwave, cavity resonators. Okay, but in advanced electromagnetics or in the modern electromagnetics, we use the periodic structure or metamaterials. And these structures manipulates the wave in different ways that a normal material which is found in the nature cannot do this. Okay, so they have the repeated pattern, so that is why we say these materials have the periodic property. So in periodic material, like we have a substrate, and let us suppose we have some geometry on it. Now this geometrical structure is repeated in nature, and we can divide it into multiple cells. So this one is one unit cell and it contains some property. So when we apply the electromagnetic wave from this side or from this side, it will pass through this unit cell and there is a phase shift from this point to this point. So it will decide that this wave will propagate from this structure or it will be reflect back. So this is the property of periodic structure, and they always follow the Bragg diffraction. These periodic structures can be one-dimensional, two-dimensional, or 3D grid type. Here you can see in this image, these are various kind of periodic structures. So in modern electromagnetics, modern electromagnetics, you will always deal with the periodic structure. There is only one structure, that is defective ground surface, where you will not found the where periodicity is not necessary, and apart from this, all the structures will follow the periodicity. So first term, what is the periodic structures? Now, next is metamaterials. In metamaterials, we have we have a combination of periodic structure, and the property of metamaterial is it contains negative value of permittivity and negative value of permeability, and also because of all these negative value of refraction index. So negative refractive index means it represents the backward waves. So when a wave incident from one medium and enter into the another medium, it get refracted and some of the portion of the wave is reflected. But when we have negative refractive index, it seems like the wave is it seems like that wave is moving in the backward direction, not in the forward direction. Okay, so metamaterial contain these kind of properties which is not found in the natural materials. So this is a necessary condition for metamaterial that both epsilon and mu will be negative. The structure will be periodic. There is a combination of rings, split rings, and a thin wire at the back side of these split rings, which makes both values epsilon and mu negative. Next structure is the zero index material and meander line structure. So in zero index material, the value of epsilon or the value of mu is nearly equal to zero. So this is also called near zero materials. Again, they have periodic structure. Here you can see that it contain also periodic structures. The another property of this is they contain the infinite phase. So infinite phase means, or we can say phase velocity is infinite. Phase velocity is equal to infinite. It means the entire structure contain the same phase. Phase will not change from one point to another point. So this kind of structure is called the zero index material. And these kind of materials used in the leaky wave antenna where we have to require highly directional electromagnetic wave. Next is meander line structure. So in meander line structure we have this zigzag kind of pattern. In the second figure you can see we have this zigzag kind of patterns. So at the actual physical area of this page is something like this. But by using this zigzag pattern, we increase the electrical length of the antenna or radiator in the given physical area. So this kind of structure is used in the antenna miniaturization or compact phase shifter or polarizer. The next structure is the electromagnetic bandgap structure. So in electromagnetic bandgap structure, it's a high impedance surface and they are used for suppressing the surface waves. Surface waves are harmful for the microstrip line or strip line kind of structures. We will discuss separately in detail that what is surface waves. So they have the property of isolation and they reduce the mutual coupling between antenna elements and they increase the antenna gain and preventing power leakage into the substrate. So in this structure you can see there is a microstrip page and a ground surface and there is a via. This dot shows a via which sort the page and ground. This is also conducting wire. So here you can see that this kind of periodicity you will found in electromagnetic bandgap structure. So they use in the MIMO antennas, that is multiple input, multiple output, used in mobile communication application. By using dispersion diagram, you can found that which kind of frequency band they can stop and which frequency band they will pass. Next is frequency selective surfaces. So in frequency selective surfaces, they are also two-dimensional and they have different kind of shapes of unit cell like tripods, crosses, rings. So here you can see all these different kind of shapes which can use to make the frequency selective surfaces. They can be low pass, high pass, band pass or band stop filters. So again they are periodic structure but there is no compulsion of negative epsilon and negative mu. This is the compulsory condition only for the metamaterials. They are periodic, but they will not follow this kind of rules. So the frequency selective surfaces are used in the redomes for allowing the radar signals and blocking other signals. They are also used for smart wallpapers for signal isolation. In defected ground structure, these are created by etching the defects or slots or some other kind of patterns as shown in this figure in the ground plane. So when we modify the ground plane, we modify the electromagnetic behavior of the waves. So when we create so when we create the disturbance in the ground plane, there is a change in the current flow, and because of change in the current flow, there is a change in the response. So the defected ground structure are also same as the electromagnetic bandgap EBG structures. They act like a LC circuit. They created band stop characteristics and they improve the impedance matching. So mostly they are used as a filter or used in the compact antenna and also used as a harmonic suppressor. And the last one is the chiral ground structure. So these chiral ground structures are in the spiral form or in the helical form or in the twisted element form. They have asymmetric behavior or we can say lack mirror symmetry. They interact differently with left hand and right hand circular polarization. So mostly they are used in the polarization application or optical activity. When we pass an electromagnetic wave through these chiral ground structure, they will change the polarization of the wave, or we can say they are used as a polarization rotation. There is one more name, that is artificial magnetic conductor. So they are specially engineered surface that reflects electromagnetic wave without phase reversal. It means there is no reflection of the phase, or we can say the value of reflection phase will be equal to 0. So they behave like a ideal magnetic conductor over a certain frequency band. So we have a perfect electric conductor PEC, or we can say metallic surface. So they have a phase reflection of 180 degree. But in case of artificial magnetic conductor, there is a reflection phase. There is no reflection phase, or the value of reflection phase is 0 degree. So EBG structure and AMC structure, they are one and same thing. They are used in low profile antennas for gain enhancement, surface wave separation, mobile and wearable antennas, and for satellite communication. So in this lecture, we have seen different kind of metamaterials, and these are one similarity in all these metamaterials, they are periodic in nature. Second, the metamaterials are different from other periodic structure because metamaterial have the property of epsilon mu and epsilon negative, which makes these materials uh, very different from the other materials. And the size of these materials are very less. That here you can see that space between P is the space between two unit cells. So if we have one unit cell and this is our second unit cell, we have some this kind of geometry, and this is also again this kind of geometry. So the distance between these two, this is P. So this distance is much less than lambda, or by thumb rule it should be lambda by 10. So the application of metamaterials are clocking, miniaturization of antenna, gain enhancement of the antenna, then Zero index material or near zero material, they have infinite phase velocity, electromagnetic band gaps used for the surface wave suppression. The size of ZIM is also less, much less than lambda. Again, it will follow the lambda by 10 dimension. For EBG, the dimension should be lambda by 2 or nearly equal to lambda by 2. The application is for MIMO isolation. Then frequency selective surfaces, again the same dimension. They are used in the redomes or for blocking the radiation. And then Chiral Metamaterial used as a polarizer or in polarization application. So now I suppose that the confusion between different structure is now clear. And still, if you have problem, you can comment it. Thank you.